Welcome everyone to our Alfasoft online demo day, and thank you for joining us today. My name is Torgrim Sandvold, and I'm the product manager for statistics and data analysis here at our Norwegian office. In the next webinar, we will be presenting SigmaPlot, data visualization and statistics with SigmaPlot, and it's given by Sebastian Wassenberg from Germany. But before we start, just a little housekeeping. If you have any questions during the presentation, please type them into your question box in the GoToWebinar panel on your right. We will try to answer them during the presentation, and we will also hopefully have time for some questions at the end. You will all be muted during the presentation to avoid any audio problems. And please note that we will be recording this webinar, and both the recording and the questions from this session will be answered and made available to you afterwards. We will send you all an email with links to the recordings, the question and answers, and any related resources as soon as we have edited them and published them, hopefully by mid next week. With that, Sebastian, I will hand over the screen to you so you can get started with your presentation. Just a second.
Yeah, okay. Can you hear me? Yeah.
Yeah, I can hear you, and I can see your screen clear. So you're ready for your presentation. Good luck, Sebastian.
Yeah, thank you, Torgrim. Yeah, hello, everyone. Welcome to a quick introduction to SigmaPlot. It's a tool for data visualization and statistics. And yeah, I want to show you a little bit what you can do with it. So just a quick introduction for me. My name is Sebastian Wassenberg. I'm a data analyst since 2012, so since 10 years I play with numbers and try to visualize them. And usually I work with medical, biological, psychological data, but in fact the numbers, the statistics, and even the plots don't care about the content. You can visualize anything, whatever it is. And yeah, but I choose some medical data because I'm familiar with them. So we will have some examples from this field. And one more thing, I'm not a developer of SigmaPlot. I'm not involved in the development. I'm just a user and also a kind of fresh user. I'm using it since a few months. So I learned something, maybe not all, but I will show you what I found out and the things I like most about SigmaPlot. What is SigmaPlot? First, there were two solutions. There were one software tool for data visualization called SigmaPlot, and there was another one called SigmaStat. It was dedicated for statistical analysis, and now they merged them both together. So when you have SigmaPlot, at least version 14, I think, or 13 even, the latest one is 14.5, you have both. It's integrated in SigmaPlot, so SigmaStat is now part of SigmaPlot, no more two separate software solutions, one. And it's perfect because now you are able to perform a statistical analysis and you can visualize your results. And the great advantage of SigmaPlot is that you get not only some kind of graphs, you get publication-ready graphs. So something you can send to a journal and they will be happy to use your graphs. It's not always the case with other graphs, maybe something you exported from Excel also. You will get a nice note from the journal that you should hand in your images in another format. most likely. So you don't have this problem when you create your graphs with SigmaPlot. My favorites in SigmaPlot are these things. You have guided dialogues. I will show you in a minute what I mean. That will help you to choose the appropriate graph and also to choose the appropriate statistical method you kind of should use or can use. It's not always that easy to find the appropriate test for your data. We will see this in a minute as well. But you have this kind of advice you get from the SigmaPlot. And so it's perfect for non-statisticians and not only for non-statisticians, also experts can benefit from this because there are so much options. You can't know them all. Okay, when you're a data analyst like me, you should know them all. But even then, there are new developments every time, and it's getting harder to keep up, like in any other field. And one more thing, you have a flexible data input for graphs and statistical analysis. I will show you this in a minute as well. And the third thing, and I think it's the best feature of SigmaPlot, is that you can adjust everything, really everything. And they have nice presets for specific measures you want to plot in your data, like the error bars, what should you print there, and so on. It's really, really nice. I didn't find this kind of adjustment in any other program, not the one based on the menu-driven program. So it's, I think, quite unique for a SigmaPlot. What I missed in other programs, here are a few things. For example, when you like to add a break to an axis, it's not very easy to do in other programs, and maybe sometimes you are not even able to do it in any way. So that's something you won't use every time, of course, but it's nice to have this option, and it's very easy to get there with SigmaPlot. And another thing as well, box plots. Box plots are quite often used to summarize data for metric data, where you measure like some height of something or weight or any other well-used concentrations or whatever. You could use a box plot to visualize your results. And the box plot is usually missing the mean because you won't print the mean in a box plot. You will show the median and the quartiles. You don't show the mean. But sometimes when you have values like concentrations or whatever, you want also to show the mean of the values. And so it would be nice to get the mean into the box plot as well. And that's one thing you can, there's a checkbox for this in SigmaPlot. So again, an easy way to add this, and to add the mean to a box plot is a hard thing to do in other programs. So there's not only a checkbox, you have to do many other adjustments to get there. And sometimes you don't even have the option. You can arrange multiple graphs very easily with SigmaPlot. So you have a page where you can arrange multiple graphs at once. Like you saw maybe in some papers where they have not only one plot per page, but they have 4 plots, for example. You can create this with SigmaPlot as well. And sorry, I'm a data analyst, so I'm focused on statistical analysis. And here's the thing about statistical analysis. You can run them, not all of them, of course, but when it comes to the comparison of groups, you can run the statistical analysis based on summary statistics. You don't need a raw data. You just type in the sample size, the mean, and the standard deviation, and there you go. So it's very easy to run, for example, analysis or your own comparisons based on data you found in some paper. Maybe they didn't run or they didn't report the comparison that you are interested in. If you have the data, the mean, the standard deviation, the sample size, you can perform this computation, this comparison on your own with SigmaPlot. Very easy. Yeah, let's get to SigmaPlot. Not only talk about it, we want to show you something. We want to see the program. And I will start with a very simple and generic example. An example where you have two treatments and you want to compare them. Let's say two treatments for virus infection. Oh, wonder what this might be. And we want to answer this question: is there a statistical significant difference between them? That's one thing we want to answer. And of course, we want to create some charts to visualize the results. So, okay, I will switch to SigmaPlot. It's Windows only, so I have to use Windows even on a Mac. But as you can see, I'm on a Mac. You can see it here. You can run, of course, SigmaPlot on a Mac with a virtual machine tool. I use Parallels for this. And yeah, so no reason to use it on a Mac as well. I of course prepared some data that you could see here. And there are many ways to create plots in SigmaPlot. And I just mentioned that there are several ways. On the slides, you saw flexible data input. So that's the variety of methods you can enter data. And maybe you get lost, that you ask yourself, how should I enter data here in SigmaPlot? Then you won't start here with create a new blank notebook or something like this. Just switch to create graph. And this is a very helpful overview because you have all the kind of charts and plots you can create with SigmaPlot. And for example, here with the scatter plot, you also see the worksheet preview. So the way how you should enter your data. Like here, if you have a scatter plot, just one column for the X values, one column for the Y values. Or if you want to have an error bar plot, for example, like I choose this one, like this, where you have again X and Y values, of course, and you have an error bar with the same arrow going up and down, so it's a symmetrical error bar here. You see how you enter this. You have X values, Y values, and the error for the Y. And maybe you have a second data set here you want to print, then you have Y2 and so on. So a nice overview, and not just an overview, you also get explanations here. One column X, multiple Y columns, and so on and so on. So it's not only just structured here, it's also very informative how you should enter your data. And that's a great way to start if you don't know where to start. I click on cancel because I prepared something for us. So I open just the notebook I created with some demo values, some demo data. And I mentioned that I want to compare two treatments for a virus infection. And of course, there are many measures to measure the viral load, for example. And I think one value we learned about in the last 2 years is the CT value. It's not a very good value to measure your viral load, but it's an easy one to get. So just we use this here. Let's imagine these are CT values. CT stands for cycle threshold, and usually the CT value is correlated or associated with the viral load. The lower the CT value is, the higher the viral load is, and the higher the CT value, the lower the viral load is usually. So we have this drug A and drug B, sorry, and I want to compare them. So I highlight these columns, and here we have this Windows-like ribbon menu that you might know from the Office package from Microsoft, for example. It's the same, not the same, of course, with all the options. We have the home screen, we have something for the worksheet where you, for example, can format your cells. I want to show you this. For example, you don't need these decimal places. We don't need 4 decimal places. I can change it here to 0. It's much nicer now, not too much numbers here. We have, of course, the create graph section. We have a graph page section and analysis. And first I want to go to analysis because I want to first analyze these data. Is there a difference between drug A and drug B? And maybe I don't know what test should I use. So I need a little help. And here I get this help. There is the advisor, the guided dialog. I click on this. And then I'm asked some questions. What do you need to do? Describe your data, compare groups. Compare groups, that's what I want. You see there are a lot of other tests as well. I just stick with the second one because I want to compare groups. And I want to know if there is a significant difference between them. So I go to next. Then I'm asked, how are the data measured? By numeric values. That's the thing I called metric data. Is it by rank? It's usually the case if you have something like grades going from low to high, or like this: poor, fair, good, excellent, and so on. Or proportions, where you only have categories. I have numeric values. I have the CT value. Okay, next. Then, did you apply more than one treatment per subject? No, we didn't, because one person was treated with either B or A, not both together, or first A, then B. No, they get only one treatment. So not more than one treatment per subject. And then I'm asked, okay, how many groups I want to compare? It's 2. And finish, and then I get my suggestion, a t-test. Perfect. Okay, let's run it. We have this window here. And again, you see the way how you should enter your data, or you can enter your data to compute a t-test, for example. This would be the format when you have the raw data. So one column is one group. And that's why I have here a column for drug A. That's the drug A group and the drug B group. And you can also choose another data format. For example, that you have index data, like you have a column with the category, say A and B. And then you have the CT values in another column. You can use it as well. Or here you see that we don't need the raw data at all. we can just use the mean for drug A group and the mean for the drug B group, the sample size and the standard deviation. We could also compute the t-test for this. We have the raw data. So we stick to raw. I click on next. Then I'm asked to select the columns. It's already done when because I highlighted them first. If you don't highlight them first, then just select them here and you're ready to go. Yeah, we are ready to go, so we finish. Okay, there's another thing. Normality test failed. Ooh, we failed in something. That's not so good. It's good that SigmaPlot noticed this, because the assumption of normality is something that you will encounter very often when you have statistical tests. So you should be aware, is this assumption, will this assumption hold for your data or not? And there are tests for this, and they are implemented in SigmaPlot as well. And you don't have to run them first. They are, for some tests, they are run. It's a preset that they are run. So we get this result here, and we get the suggestion that we shouldn't use or might not use the t-test. It would be more appropriate to run the Mann-Whitney rank sum test. I want to stick to the t-test. I want to compare the means. So I don't want to run this test now. We will run it in a minute. For now, I don't want to run it. I want to run the t-test. So I click here on no, because I don't want a Mann-Whitney test. And there we have it, our results for the t-test with a lot of information. Here we get the result for our normality test. We already saw, okay, we failed it because the p-value is below 0.05. Usually you want a small p-value because you want to have a significant result, because the result is significant, or in most cases it's defined as statistically significant when you have a p-value below 0.05. But it's you don't want to have a difference here for the normality test, because it will tell you that there is a deviation from the normality distribution or normal distribution, and you don't want this kind of difference usually. But for now, we just ignore it. Then there is another thing with the t-test. When you compare independent groups, there's another assumption, the assumption of equal variances within each group. And there we have also a test for this, and we passed this one. So here again, you get more informative results than with any other program. Most statistic program will give you a p-value, and then maybe you think, okay, and now what? What can I do with this number? And so it's quite nice that you get the interpretation of this value as well here with SigmaPlot. And of course, we can get the results. You also get a kind of narrative result, a little text. What does this mean, what we have here? Yeah, what is the purpose of this test? We get our means, we get standard deviation, and we see, okay, there is no difference in the means of these two drug groups. So we can now tell, okay, there might not be a significant difference between them. And when we have a look at the p-value of the t-test, yeah, it's 1. It's not actually, it's not 1. It's very close to 1, because it can never be exactly 1. But it's a very, very high p-value, and so there is no significant difference between those two groups. And again, here we have this narrative result for this. There is no statistically significant difference between the input groups. the two groups A and B we have here in our sample. So you would say, okay, there is no difference. Okay, maybe you want to visualize these results. We can do it from the analysis panel here as well. We can create a result graph. And with the t-test, when you want to compare groups, there are some options you can choose. I first want a bar column means. And there we have it. This is our graph. You see, I created a new page. We can arrange them in a vertical way like this. So we can have both in one view, if you like. And of course, we can switch it if you like as well. I will close the other windows or the other tabs, and I will make this one bigger. Because maybe you say, oh, that's not a nice graph. It's only black and white, only lines. And I told you at the start, you can adjust everything. So let's just do this. I myself, I don't like these columns, these lines here, the border. And as you can see, when you go over the graph, you have you can click on almost anything. Of course, sometimes it's working in this demo and sometimes not, like in a usual demo. You have this mini toolbars here, where you, for example, can choose the color or what kind of axis do you want to plot here, or how big the line should be, what kind of line, for example, yeah, not for the border here. And yeah, you can adjust it here right away. I just choose the color because I don't want to have anyone. And maybe you think, oh, now my y-axis is gone here as well. Yeah, it looks that way, but we can just edit this as well and tell them again it should be black. Now you might see, oh, it's back here. So maybe it's not the only option to get rid of this value of this axis. You can also right click and then we have hide. And okay, now it's gone. And yeah, maybe you think, okay, this doesn't look nice at all. And maybe again, of course, the demo. So I have to click a lot. So I want to hide this. So yeah, you can use this mini toolbar. You see, it's maybe a bit tedious if you want to click on everything. So if you want to address more options, right click again, and then you have here the graph properties. It's another window, it's this one. And there you can address all the things I've done with the mini toolbars in one place. For example, I don't like this this y-axis goes from -20 to 140. We don't need this, so okay, I address the scaling of not the x data, the y data. I don't want it to start at 20, I want to start it at 0. And the error bar here, it goes to around 60, so 140, no, it's too much. Just 80 should be fine. Okay, great. So we have this. And of course, we could have a look at the error bars. They are created right away. We didn't choose what the error bars should represent. And here we have the perfect preset because it should be the standard deviation that you should print as error bars. Of course, you could change it to maybe not one standard deviation, but 2 or 3, or you want to plot a standard error, or you want to plot the confidence interval, the 95% or the 99%, or you want to plot the percentiles or the highest or whatever value. So you have a lot of options to choose from. You don't have to compute the values on your own. They are computed based on the raw data. So you can adjust it here if you want to. I don't want to, because the standard deviation times 1 is perfect. So you just leave it this way. And you could choose also, when we have here the data point, it's the mean. The mean is the top of the bar. Here again something, you can also enter the data you want to plot. So if you enter the means in the worksheet, you can just choose this here from columns, and then these means are plotted. They are not computed on your raw data. You could enter them and then plot them as well. And this is the case for almost anything. Like the error bar, what should it represent, what value should it have, even colors and stuff like that you can define in your worksheet, which color should be used in your graph. So you have many options to address this. Yeah, I want to pimp this graph a little more, because I'm a person that doesn't like the axis at all. Of course, there should be an axis, a y-axis, but I don't like the lines, so I just get rid of them. And I don't want the ticks. I don't like them as well. So just switch to major ticks, and okay, I don't want them. So maybe now you would think, okay, how should I know what value this might be? Is it between 40 and 20 and so? So maybe grid lines would be great. Of course, we have them as well. Here, graph, grids. I want to have major grid lines for the y-axis, and I just choose a color or a line, and then I have them. Okay, they shouldn't be black. I want them to be gray. And maybe you think, okay, the color is restricted to these values. Of course, you have some options here, but again, there is custom. And when you click there, you can choose from this color preset, or of course, you can define your very own color palette as well. For example, you want to keep your corporate design or something, or the corporate design of your institution, whatever, and you can address it here. So I want a gray grid lines, this one. And so we have this, and yeah, I also like to have a bit more color here. Of course, we don't need it in a graph with only 2 bars, because the bars represent different groups, so why use color? But I just want to show you how you could use this. For example, no, I don't want them to be white. I don't want them to be just one color. For example, I choose green, then both are green. If you like them to have different colors, okay, then I choose a color scheme. We have a few color schemes. Oh, party sounds nice. So let's have a little party here. And okay, and now they're red and blue. And as I already told you, I don't like borders in these graphs. So why use borders for our columns? We don't need them. The column, the bar itself is enough. Maybe you wonder, okay, when I change the color, the pattern and the edge to white, oh no, my error bars are gone. Again, don't worry. Here we have our error bars, and we can define their own color. So it's not white, it should be black again. And there they are. So, and I think that's a much nicer graph now, more minimalistic without the borders, a bit more colorful. So, okay, it's not something you would use in a publication, of course, in an academic paper. Usually you won't use that much color for 2 bars, but if you want to have it in a presentation or so, it's great to have another distinction between them. Yeah, you can, of course, add a title to the y-axis. It's the CT value we have here. So just double click on this. I think the x-axis is explains itself. So I don't want a title for this. So just get rid of this. And yeah, I keep this here. Bar chart color means. Okay, here we have our plot. Maybe you think, okay, why should I use SigmaPlot for this? Where is the point? You have very much options. I can't show you all of them, and they are very easy to use. So you have, for example, the ticks. They are you can change it in any way. You can even set the ticks you want to display. It's nothing you can do with like Excel, for example. You can't choose manually that you want to have a tick, a major tick, like the first one should be 25 and the other one should be 30 and then the next one should be 75 or whatever. They usually follow some kind of interval. And here with SigmaPlot, you can even address this and make it your own. Yeah. And of course, we want to have publication-ready graphs. So we want to get this graph out of SigmaPlot. And to export a graph, I go to Home. And then here I have this little icon with the file, with the arrow going out. It's the export option, and I want to export it. And of course, we are in a directory that I used for this presentation. And here we have save as type. And here are the options you have with SigmaPlot to get graphs out of SigmaPlot in another format. And of course, maybe you think, okay, I choose some pixel-based format like PNG or JPEG, GIF. I wouldn't recommend this. We can create a PDF, for example. And with PDF, you have 2 options here in SigmaPlot, PDF vector and PDF raster. And I will show you the difference between them. I first choose vector and create this graph. Okay, I'm asked about the size. What should be the final size? I stick with the A4 format here. And of course, the DPI is something very important. It's something like how sharp the graph will be. The higher the value, the more the sharper it sounds, the clearer the graph will be. But as well, if you use a high DPI, the file size will increase. Not within vector-based, not usually within vector-based file format, but within pixel-based. So I stick with 300, should be good enough. And click on OK. And then let's have a look at the graph I created, the file. It's this one here, our nice bar chart. So it's very easy to get it out of SigmaPlot. That's the vector version. And of course, I want to show you the other version as well. raster. I call it raster. Save. Yeah, same settings here, and I open it as well here. And maybe you think, oh, where's the difference? It's the same graph. Yes, it is, but with a few I can show you the difference when I zoom in. Here it's the vector, not the raster. So you can see, like here with this these labels, they get a big pixeled, and you won't have this with a vector-based graph. So here again, you see this one is clear, this one is clearly not. And that's the difference, the huge difference between pixel-based file formats and vector-based file formats. And I would recommend that you should go for a vector-based file format. You could use PDF. Some journals don't like them because some other programs can't use PDF. So you could use another format that is used quite often for vector-based formats is this one, EPS. It's also vector-based, and usually it's transformed into a PDF by most operating systems, but it's something you are something it's used for printing quite often. So you can export it as this as well. Okay, so that's for the options here. And I want to go back to our data because I wanted to show you something else. When I run this analysis, I just rerun my t-test, finish. We encountered this notice. Oh, normality test failed. Do you want to run the Mann-Whitney test? Okay, we run it because if there's something not right with our data, so normality failed, maybe you should run another test. Here we have the Mann-Whitney rank sum test, our result here, and now we see we have a significant difference. There is a statistically significant difference between those two groups. The t-test told us no, there is no significant difference between them. How can we explain these results? Maybe you should use another graph for this, and I want to create another one. I want to create a box plot, this one. Yes, I have this. I want to box for A and B and finish. That looks very different, like our bar chart. Our bar chart is this. Our box plot looks like this. Of course, I can modify it the way I did with the bar chart, but for time reasons, I will skip this part. I just want to show you where the difference is. We have a box plot, and you can't see the box at all because we have this very high value here, 120. So maybe we should break the y-axis, and that's what I want to do now. And you see axis here, we have breaks, and just switch to y data, and then I can enter a break here. For example, most data is more, not even higher than 40. So let's start the break at 40 and we go up to 100. And there we have our break. Now the boxes are a bit, yeah, they are small after all, but a bit larger than before. And we have this nice break here. It's very easy to create in SigmaPlot. And I already mentioned that you don't have the mean in a box plot. we have the median. The line here within the box is the median. So 50% of the persons in group 2 in our group B have a CT value less than, I think, 30 it is. And 50% have a value above this. And we see almost all persons in group 1 and group A have a lower CT value than in group B. So drug A might be better. No, might not be better, because a low CT value is associated with a higher viral load. So a higher CT value would be better in a way that it's associated with a lower viral load. So drug B might be better, even statistically significant better than drug A when we use a Mann-Whitney rank sum test, because it compares the height of the values between them, and the mean can be biased by some outliers. For example, this value here. I just plot the mean into this graph here. When you have a box plot, you have sometimes special options here in the plot section of the graph properties. When you have a scatter plot, you have some other options here, data fields and bars, and so the symbols you have always, but bars, of course, only if you have bars, and box options only when you have a box plot. And there it is, the checkbox I told you about. We have the show mean line checkbox. So I can click on this. I will give them another color. Let's say, yeah, something bright, this neon blue, for example, cyan. And we see now where's the difference. The t-test compares the mean. So the mean is the same in both groups, okay? And when you use a t-test, the t-test compares the two means. We see, or we would conclude that there's no difference. If you use A or B, it doesn't matter. When we compare the ranks of the values, the height of the values, we see there is a difference between them. So that's why you should visualize your data always. And with SigmaPlot, you can even create a box plot with the mean, so you get a sense of what a t-test would tell you and what a non-parametric test like the Mann-Whitney test will tell you. So that's quite nice. Yeah. Here is the another little comic for this. Always think about the adequate statistics and the adequate plot according to the statistics you want to plot, because that's something you should think about every time. Should I use the mean? Is the mean an appropriate and adequate statistic to summarize my data? So you can see here, maybe it's not. If you have this bar chart here with the error bar, okay, you get a mean that is between those values here. You have 4 very low values, 3 very high values. The mean is between them. And you might think, okay, the mean is this value, but no one has this mean. The mean value doesn't exist. It's usually a fictional value. So when you have a box plot, you see more of this kind of data. So that's why a box plot is usually preferred over these kind of bar charts with the error bar. Sometimes they are called dynamite plots because it's the handle of this thing, the device you use to blow something up. And yeah, that's why they are sometimes called dynamite plots, these bar plots. So always think about it. And of course, there are some other examples I wanted to show you. The time is running out. So I just I showed you already that you could use the not the raw data. You can use the summary statistics. Just a quick example for this. For example, we have a study. I don't want to mention any more about the study, but it's this one. Maybe you come across some table, doesn't matter where it's from, and you have these 4 groups, and you just see, okay, they compared all 4 groups, and now you see, okay, there's a difference between them. And maybe you want to know where is the difference? They didn't report the pairwise comparisons for these values. So maybe you want to run this analysis on your own. And I prepared this that we want to compare, for example, the age. And I just have to enter here the sample size. The daily group is missing. It's sample size 776. The mean 44.2. And the standard deviation 15.3. So here again, I can choose analyze. This time I want to run the one-way ANOVA. I already know this. And the program is clever, so it detects, it's another way how you answered your data now. It already suggests, oh, it might be mean, the size, and the standard deviation, and it's correct. Okay, of course, I have to select the column with the mean, the column with the sample size, the column with the standard deviation. I click on finish. Yes, I want to run the pairwise comparison as well. And now we have it. We have the same analysis of variance that they run in this paper as well. And we get now the pairwise comparisons, the comparisons that were not reported in this paper. And here you see you can easily recreate them, reanalyze this data with SigmaPlot. You can, of course, visualize them as well, but I want to skip this now. And some other thing, a quite nice study I came across, and that's something I want to show you in the last minutes, is this one. Of course, you find many paper now about COVID-19 and maybe what is the risk factor that you get COVID-19 infection, and maybe there are some preventive measures you could use or do to lower the risk and the odds for getting an infection. And when we have a look at this charts here, you might think of, oh, cool, it's red wine. Because here we have, it's kind of a forest plot. It's the result of a binary logistic regression that is plotted here. We have the odds ratio. And here the odds are plotted for an COVID-19 infection. So that means a value above 1, an odds ratio above 1 would mean that we have an increased odds for getting an COVID-19 infection. And the value below 1 means that the risk, the odds are lower to get a COVID-19 infection. And when we see here, when we drink 1 to 2 glasses red wine per week, our odds for a COVID-19 infection is significantly lower. And it's even lower the more red wine we drink. Oh, that's nice. Finally, a reason for day drinking. And yeah, that would be the message with this paper. But if you look at beer, you shouldn't drink beer, because if you consume more beer, the higher the odds are for a COVID-19 infection. And of course, it's a nice example, and it's a published one for an introductory statistics course, because you might think of another reason why these people here, the people that drink a lot of red wine and the people that drink a lot of beer, might show this pattern here. Think about where and when you consume these beverages. this might be the key to explain these results. So don't be fooled, don't think, oh, I opened the first bottle of wine now and then I'm safe, safe for COVID-19. No, I think that's not the correct conclusion you should draw from this data. But why should I, did I show you this? I have an example for this as well here. I have to close a few windows because I wanted to show you that you can create this kind of graph. It's a very special one with SigmaPlot as well. Of course, I can't show you all in the last 5 minutes. I just want to show you the final result, and that is this one. And of course, you get all the files with the, I presented you here, so you can try it on your own with a trial version of SigmaPlot, how to get to this result. I just want to show you that it's possible to create even these kind of very, very special results, and not special results, special graph here with SigmaPlot. It's not the same, of course, but it's very like the one we saw in the paper. We can address the label position. Maybe you see here I'm going up from going down from 0 to -10. We have a break here, -4 and then -6. That's the break we see here. And I can even use some kind of label for the tick values. Usually, you will see this kind of graph. Wait, this one with numbers, and with SigmaPlot, you can tell the program, no, don't use these numbers. Use my own labels I want to use, and you enter these labels in your worksheet as well. And then you get your own labels, this one here. And you can even format them. So maybe you see the red wine here is a little bigger, and beer cider is also bigger and more bold than the labels here beneath. It's something you can do within the worksheet, because you can click on cell, right click, choose format text, format it in any way with some kind of font or color, whatever you want. And it's just the way it's shown in the graph. So it's perfect to individualize your graphs in a variety of ways. You can do it with SigmaPlot as well. Of course, maybe I show this to you in another webinar next time when I focus on this to create more advanced versions of graphs here. Because okay, bar plot is nothing very special, but I wanted to show you many ways to adjust it. And with this plot, I want to show you that you can create highly individualized plots with SigmaPlot as well. And of course, here we have the red wine, the red color for the red wine.
Bastian, sorry, I think I have to stop you there. It was very interesting. It's a great presentation. And I guess we will be seeing you on Thursday, the German day. So you will be back?
Yeah, I will be back. Just a few words more. When you want to use SigmaPlot, of course, there are more tutorials, manuals, and examples in SigmaPlot. Just click on the upper right corner. And of course, if you have questions regarding this program, whatever kind of questions, please feel free to drop an email to get in touch via this email address here, savescontact@inpixel.com. This is the way to go. Yeah. Thank you.
Great. Thank you, Sebastian. I will switch over to my screen.